100 years ago, Victor Hugo wrote, "Where the telescope ends, the microscope begins. But which of the two has the grander view?" Today, we still seek the answer. A Fine Science with Holly Preston.
High tech. The expression is slightly overused, but it best describes some of the things coming up on this program. We'll look at a system called CAD/CAM, Computer-Aided Design, Computer-Aided Manufacturing. It's a sophisticated tool that applies computer technology to industry. We'll also visit a specialized weather station. Every hour it monitors conditions, everything from air and soil temperature to the amount of bright sunlight. Later, we'll look at another type of monitoring station, an operation that's totally automated. It measures the amount of air pollutants being emitted by an oil refinery. Another high-tech area we'll look at is fiber optic communication. But first, a science called remote sensing. The term means exactly what it implies: sensing or collecting data without physical contact.
We're involved with the remote sensing satellites that are directed towards Earth resources. So we're involved with a series of satellites called Landsat, which really look at land-based Earth resources. And then we're involved receiving a series of weather satellites that are called the NOAA series of weather satellites, but we use them for applications other than weather. We use them for forest fire, ice reconnaissance, disease force, things of that nature. The information is stored on high-density digital magnetic tape. We use rather large reels of magnetic tape, 1 inch in width, that are capable of recording up to 240 million samples of information per second. So we record the satellite data on the magnetic tape, which is retained as our archival source. And a large number of years from now, we can go pull that tape from the archive and produce data of a given area. The largest single users right now would probably be government, because it's still experimental in nature, and the federal government, provincial governments, and then private industry. In private industry, oil companies, forestry companies, companies interested in exploration.
We have 8 demonstration projects presently underway to demonstrate the cost effectiveness of doing these projects. We have one on moose habitat mapping, deer habitat mapping, and caribou habitat mapping. Those are the wildlife sorts of events. We also have them in the forestry area for burns and cutover, and also for forestry inventory to make a replacement of the present forest inventory maps. We're also doing crop for crop insurance and also for the Canada Census. We're also doing another one on high salinity areas and irrigated areas. The information is for the Landsat is received at Prince Albert. We receive the data tapes from Prince Albert and put them onto our computer here, which is loaned to us by the Canada Centre for Remote Sensing. We're doing a technology enhancement or transfer program from the federal government to the provincial government.
If I were a rancher in southern Saskatchewan, how would I be able to make use of this system?
One program that we're trying to introduce into Saskatchewan that is presently in Alberta is that rangeland management techniques are used there. They get an image which has been enhanced to tell them how well the grasses have been used. So it becomes a management tool, particularly in the fall and the spring, to predict what or how they can use a particular pasture or how well it's been used in the past.
And one of the factors would be time saving, I suppose.
Time saving in that they don't have to go out and specifically cover the whole of their pasture land. They would cross-check particular areas of particular interest.
Is this expensive to the rancher?
We don't know what the cost will be at the moment. In Alberta, they subsidize it and they charge about $60 for the image.
We provide a wide range of what we call secondary products that we produce from the archive tape that I mentioned previously. That is black and white photographic products, in terms of prints and transparencies. Color photographic products in terms of color prints and transparencies, and computer compatible tapes. The two most common now are computer compatible tapes, because the larger users have their own computer processing systems, and color prints and color transparencies.
Now you do a lot of photographic work in this location?
Yes, the actual reception, recording, processing, and secondary products such as photographic products are produced on site.
What types of things are the users looking for?
Oh, there's a wide range and scope of applications, but again, it primarily refers to is related to earth resources. In agriculture, they can tell the types of crops, whether they're diseased, whether they're healthy, the moisture content, the best fertilizers used. Geology, they discovered nickel mines, copper mines, uranium mines that I know of. It's been used as court evidence in cases of pollution, hydrology applications, just a wide range of applications. This is a technology that's still in its infancy, and they're generating new generations of remote sensing satellites that have higher resolution, better spectral definition, and will provide a far greater base for the users to obtain knowledge. In other words, satellites will be able to fly over in a short period of time, and you'll be able to tell which area of the house you need insulation, that sort of thing.
So there's a long way to go in the way this information is going to be used in the future.
Yes, it's just in its infancy.
My dry cleaning isn't ready, sir. I brought it in a week ago. Yeah, that's right, the slacks, the jacket, and the dress. No, sir, the dress belongs to my wife, okay? Yeah, so it won't be ready till next week. Okay, fine, sure. How much is this going to cost me? $73.95? I tell you what, sir, no, you can keep the clothes. I am not paying these prices. Don't yell, sir. I don't care if the dress isn't your size.
When quality and service matter, try us, Queen City Cleaners, with 5 Regina locations.
Commutin', doodle-you-do. Sausage McMuffin, they're taking breakfast by the hand. All over the land. Uptown, downtown, boogieing along. Sausage McMuffin right in your hand. Sausage is catching the 805. You're taking fresh grade A along for the ride.
McDonald's Sausage McMuffin with egg will get you going. Sizzling sausage, melted cheese, and a fresh egg.
It's a good time for the great days of McDonald's. Commutin', doodle-you-do.
Nothing comes up more than the topic of weather in everyday conversation. Weather affects some people's work. It affects their holidays. For some, it affects their very livelihood. Weather has a bearing on attitudes and outlook. It shouldn't be surprising then to find a complex operation just outside of Saskatoon that records just about everything you could want to know about the weather.
At the Climate Reference Station here, we are collecting data on precipitation, air temperatures, dew point temperatures. We're recording soil temperatures. We're recording sunshine, that is bright sunshine hours, as well as we're recording radiation data, both global or direct radiation and a diffuse radiation measurement as well. We're also recording wind data. I should add one point that I did fail to mention was an evaporation measurement that we do from May to September as well. This is something we do for the Atmospheric Environment Service in that period. It's as well of use to the agricultural community, and gives us a good idea of the amount of moisture being lost to evaporation. In our measurement of precipitation, one of the instruments that we use is a tipping bucket recorder, and from it we can record the intensity of rainfall throughout the event. We have had some requests for information regarding intensities of rainstorms in the past. Essentially, that's the parameters that we are covering at SRC here. Under contract to the Atmospheric Environment Service, we submit to them monthly information on soil temperature, sunshine, air temperatures, and growing degree day data. That's what we submit to them. Much of the other data is archived at SRC in our computer, or in the computers there.
What could be an example of a practical application of some of the information you turn out?
Well, for example, we work fairly often with the University of Saskatchewan through some of their departments that require climate data. As an example, we work with grad students that may be working on some of their graduate work related to crops, and thus requiring climate data over the past 1 to 5 years perhaps. We can provide them with that sort of information.
What would be the long-term objective of this type of an operation?
Essentially, it's the climate reference station has been operating since 1965, and we've had almost a 20-year record, and I think one of the objectives is to maintain that record and to continue operating as a climate reference station. There are a couple parameters that we measure here that are not overly common or not commonly measured in the province. One of those being soil temperatures. I think we're one of, a very few number of stations in the province that record soil temperatures. We record bright sunshine hours. And those are, I think, the first two that come to mind that are not as common as others. But essentially, I think it's to maintain the record. We have a good 20-year record as it is, and we would hope to continue that.
How would one get access to the information if one were interested in for some reason?
They could contact the Saskatchewan Research Council, and our receptionist would put them in touch with the proper contacts within the council.
In an industrial society, it's important that people and industries live in harmony. Both should share in the responsibility of keeping a clean and safe environment. An air monitoring program between the Saskatchewan Department of Environment and the Co-op Oil Refinery in Regina is a step in this direction. Environment Saskatchewan has checkpoints outside of the refinery, and the refinery has checkpoints inside property lines. The refinery monitors are unmanned.
The automatic monitoring station is laboratory equipment, except it works without a technician. Each instrument is designed to look at specific gases, and we are interested particularly in the nitrous oxides, sulfur dioxides, and H2S and hydrocarbons. We have two. They are set at the areas where we have the prevailing wind, which is in the southeast section of the property as well as on the northwest corner. The air is taken in, and it's usually filtered to remove dust and other particles that we're not interested in. And then it is analyzed in the analyzer, and then this is followed by a detector that detects the components, and then this energy goes to the computer, and the computer prints out the analysis, and thus we get a permanent record. This information is brought into the laboratory, and our technicians read the results, and with the help with the computers, ours and one downtown, and all this data is put together, and this is shared with the environment people. The environment of Saskatchewan are the prime users of this information. We don't like to see things get out of hand. If there is a problem, we want to jump on it right now. The second reason, and it might be a bit selfish, we live here and we breathe the same air, and we like to see it in excellent condition.
Distinctive, warm, undeniably impressive. Just a sample of what you'll find during the 10th anniversary pre-inventory sale at Richard's Drapery and Interiors. Save 15 to 60% off selected furniture and accessories with special savings on decorator chairs by quality manufacturers. In-stock items only. Ask the staff decorators for helpful hints. Make your home look its very best during the 10th anniversary pre-inventory sale at Richard's Drapery and Interiors.
Have you heard about the great deals on combines from Sperry, New Holland?
Better than any other combine. And for the first 2 harvest seasons, you get free service checks.
You know, my New Holland dealer is right there every time I need it.
I was running circles around him, and I never threw a thing over the back.
You can count on a TR year after year.
This is the best combine I've ever owned.
See your dealer at Redline Sales Limited, 1720 Main Street North, Moose Jaw.
Hi, I'm John Veal. Join me, Betty Guild, and Dave Watson as we bring you up-to-date agricultural, resource, and business news. Weekdays on the Noon Edition. For the fertile mind.
Bring Brian Adams home. And Neil Young, Anne Murray, Gordon Lightfoot. Bring home Tears Are Not Enough, the CBC movie. Tears Are Not Enough, exclusively on CBC Enterprises Home Video. Special price $29.95 from selected video dealers across the country. Or use your credit card to order by phone. Call toll-free 1-800-268-1121. Net proceeds donated to the Northern Lights for Africa Society. CBC Enterprises, Canada's home movies.
Few high-tech developments are as impressive as fiber optics. It is being used more and more in the communications field, and Saskatchewan is a leader.
Fiber optic communication has been called the light fantastic. In simple terms, minute glass fibers are used to carry information in the form of light. The major centers in Saskatchewan are now connected. The 3,300 kilometer system carries both telephone and television signals. Capacity is growing all the time. For example, one fiber in the SaskTel system can presently carry 8,000 one-way telephone signals at the same time.
Saskatchewan in the fiber optics area is known as a world leader, and we've been asked and are performing tasks all over the world right now, which make a difference to the economic cash flows for this province. Cost-wise, it is the transmission medium of the future. In other words, it depends on this market. We have a market right now in North America, let's just talk about North America for now, that says there's so many long-distance calls being placed, and there's so many computer connections being done, and there's so many available video channels, which integrate into some cost for transmission one way or the other, and it all winds up on the consumer's plate sooner or later, as we all know. When you deal with fiber optics, you start reducing significantly by orders of magnitude, factors of 10, cost of transmission. And when you can do that, then you can reflect that in the price that you sell the thing for. And I think we all understand if something's cheaper, maybe people will buy 2, and if it's half as much, maybe they will buy 4. And when we look at what's happening in the future in terms of this information revolution, we think people are going to have to, if they're going to be a part of a revolution, they're going to have to be able to use this stuff. And that because of this tremendous cost reduction, there'll be a heck of a lot more communicating going on.
Okay, the cable is made up of a poly outer sheath. The next one is a gopher protected sheath. This is a steel sheath used to stop gophers from chewing through to our fiber. The next is another poly wrap, and the next one is an aluminum wrap, followed by paper, and then what we call angel hair. It's very fine string, and in that there's powder, and this powder is used to stop the integration of water into our fiber. The next is
And
followed by
finally,
fiber. This is
the fiber
what
itself.
all this is for.
Anywhere from
Small
6 to
hairs.
96 per cable.
In these type of cable, we can
There's also a star configuration that holds the fibers in grooves or slots to give them protection.
steel strength member.
The core of the cable is a steel strength member for construction and installation purposes.
There are many advantages to fiber optics: cost and its purity of signal. It's almost impervious to interference and things like that, which reflects how good the signal is and also how much it costs to regenerate it and the terminals themselves. But we do have one danger compared, for example, to what we call microwave radio. Microwave radio, we do have some what we call fades. There's a difference in the atmosphere or some noise problems, but we can normally switch frequencies or switch antenna locations in terms of high and low antennas and get around that. And eventually the weather will come back. Okay, as we say, God always fixes the air, but he doesn't splice fiber. And when you cut a fiber cable, you've got to fix it and fix it quite quickly. We've gone through a lot of learning on that, and we now have kind of like almost like firefighters with all their pieces ready to go, spotted in the north and the south. And if something like that happens, then we fix it. And we're getting better at it. It's happened a few times, but we're getting better at it. It's a completely different thing. And if anybody ever cuts one, I suggest you just leave town or something, because you've done a lot worse a thing than just cutting a telephone cable. You've probably knocked off a big hunk of province or something like that. The true future of fiber optics is not really, in terms of really making a difference to people's lives, is not really what we've done here in Saskatchewan yet, in terms of application. Certainly that technology is here. The real future of fiber optics is not connecting cities together. It's connecting people together directly. And when I talk about that, or people and machines, when I talk about that, I talk about everybody having a fiber in their home. Now, some people believe this, some people don't. I happen to believe it. And when everyone has a fiber in their home, it will be much like the telephone is now. You know, there's universal access service, but you will have universal access not only to telephone or somebody you want to phone someplace, but video programming. When you do that, then we have a switch network of video type programming, plus all that other good computer stuff that comes with. But I think that's the driving factor, and we're looking at that right now.
When a manufacturer wants to make a new component, the process can be long and involved. In essence, a designer would draw the component on paper. He might pass the paper on to an engineer for analysis. The engineer might then go back to the designer for modifications. Eventually, they would take the drawing to a draftsman who would create another drawing with dimensions and manufacturing instructions. That would go to the manufacturing shop, where the instructions would be keyed into the machine that would finally make the part. There's a new process that's changing that long process. It's called computer-aided design, computer-aided manufacturing, or CAD/CAM for short.
What we're talking about in this technology is the integration of all those activities. So now we have a common database where when the designer created the geometry, nobody else had to recreate it. It's all there. And the other advantage is that possibly when they get down to the machine shop, by that time the designers and the engineers have decided that there should be a modification to the design. With this system, it controls the revisions, so there's only one database, there's only one drawing that's released. And when the designer changes the released drawing, it's changed for everybody. And it's a way of controlling the drawings and the manufacturing process. That's one of the big factors, is integration, bringing together these various manufacturing aspects. Here we have this spindle, and we have used the geometry to go into an analysis program where we want to analyze the strength of this spindle. So what we see here is this spindle cut in half, so we're looking at half of the spindle, and what we call a finite element model. It's been divided into small elements that allow us to analyze how well that model will perform. So this picture is just the basic finite element mesh. Here we've taken just one wedge out of the spindle, and the last picture was a half the model, and this time we're just looking at a single wedge out of it, because in this picture we want to see if the loads that we applied are being applied in the right position. And after it's finished developing the meshes, you would have seen some red arrows appear here and some around here, which indicate that's where we applied the loads. There's bearing loads and axial thrust loads being applied. Now, if you can remember the shape of this thing, it's sitting there because the next plot is going to show you how much it bent under those loads. And you'll see how the part has been deflected in this plot. So now here you can see where the spindle has been bent right down, touching into the dialogue area. Now that deflection has been magnified 100 times as indicated here, just so that we can visualize it. But we do have an accurate measurement of how that part will deflect under those loads. Now the last picture we'll bring up here is a colored stress plot. The different colors represent different stress levels of stress in the part as a result of those loads that we applied. An engineer would watch this plot develop, and this would give him a good idea of what parts of his design are inadequate or whether they should be revised. In this particular case, you can see that there is a high stress right in this area, and the designer would look at the stress values as indicated here and decide whether that is an acceptable stress level or not, and if it's not, he would redesign and start over. Here's another example of a finite element model of a structure. In this case, it's a model of a field cultivator, similar to many that are made in Saskatchewan. And here the designer has simulated this cultivator being pulled through the field by modeling the loads that the sweeps put on the ground and the tractor pulling on it. And this has created certain stresses in this structure, and again the color stress plot indicates which members are more highly stressed than other members.
And CAD-CAM has another impressive function, high-speed hard copy reproduction. If you need to take a drawing with you, it can be done in just a few seconds right before your eyes.
And that's our program. I'm Holly Preston. Thank you for watching A Fine Science.
This is CBC Television.